Hi everyone, welcome to ANT 209. We are going to discuss today how you can build interactive analytics application using Amazon Athena. My name is Raj Devnath. I am a product manager in Amazon Athena. I have been with AWS for 3.5 years now. And my passion is building products that you, my customers, love. Along with me, I have Ravi, who is an engineer from Finra, and he would be talking about an interesting use case on interactive analytics that Finra did. Diving into the agenda, we are going to first talk of interactive analytics using Amazon Athena for Apache Spark. So, this is a new feature that we announced at re:Invent. We are going to talk through a few key use cases. We are going to show you how we can get started quickly. And finally, we are going to go into details of Finra's use case. So, yesterday in Swami's keynote, we announced that we are expanding Amazon Athena to support Apache Spark. So, with Apache Spark, you can run even more powerful interactive analytics than ever before, while at the same time getting the ease of use, the serverless, the fully managed experience of Amazon Athena. Before we dive into the feature itself, we are going to step back and look at what was the motivation, why did we actually build this feature. So, if you look at modern applications, you are going to generate a lot of data. If you are looking at what you do, you generate terabytes, petabytes of data that you put into a data lake. Now, this data itself can come from IoT, it can come from applications, it can come from e-commerce. You typically put this in a data lake and then you run analytics workloads, machine learning workloads, run your business applications on top of it. Before you do that, you typically run interactive queries, interactive SQL queries to work with the data to see what kind of data you have. SQL is great to get started. So, if you are going to query data, if you are going to extract data, you are going to join data, you are going to aggregate data, SQL is great, right. This typically takes a form of select statements, where statements, having, sum, count, aggregate. So, this is great to get started. Running with SQL is fast. This is because SQL query engines have built-in optimizers and they have ability to push down filters. And another thing that SQL engine does well is actually it moves code to the data than data to the code, which makes it really optimized in terms of performance. So, if you are looking to get started, if you are looking to do query, join or extract, SQL is a great way to get started. So, when you start to think about more complex use cases, you run into some of the challenges with SQL itself. When you start to look at things like time series forecasting, when you start to look at things like regression analysis, machine learning workloads, data science, you want to use language that has a lot more expressivity and a lot more support than what SQL provides. You are thinking functions, classes, loops. Now, SQL itself has support for these, which is actually pretty surprising. It is one of the things that SQL actually uses. But when you start to write code using this, your code starts to get progressively a lot more lengthy and harder to read. Right. So, if you look at it, you suddenly start to have 3,000 line, 5,000 line SQL programs. I know that I have written some of those, and those are challenging actually for to be able to read and to be able to debug what is happening there. Secondly, you want to be able to use an ecosystem of libraries. There is no built-in package manager for SQL. So, a lot of our customers land up writing their own code. They will end up doing this from scratch. And what we see is they are not able to use the ecosystem to expand their functionality by using third-party packages. Right. Now, there are of course different variants of SQL that provide some additional functionality, but the challenge is you land into vendor lock-in, you start to worry about interoperability. In addition to that, as you work with SQL, a few other things come up like how do I run unit test, how do I do debugging, how do I do versioning. So, if you write a long enough 3,000 line nested SQL query, starting to look at Git differences does get challenging. What we see is that for these complex analytics, complex insights, a lot of analysts are turning towards Python. So, Python is a general purpose language, a lot of expressivity. So, you can do functions, classes, loops. In addition to that, Python comes in with its own package manager, which allows you to easily extend the functionality that Python brings through third party libraries. Python has a huge ecosystem of libraries. So, if you look at PyPy, which is a repository of Python, it has more than 300,000 libraries. Right. So, it just shows that the ecosystem is a lot more mature, a lot more vibrant. Now, Python itself allows you to write unit tests. So, you can test any part of your code, whether you are looking at query statements, whether you are looking at mathematical function, you are looking at machine learning models, you can actually test any part of the Python code. Similarly, debugging is straightforward. You can run one line at a time, you can run multiple statements at a time. Versioning is easy because now you split your code base into functions and classes. It is easy to see what has changed. Now, Python is great, but again it comes up with its own limitations. The first challenge is when you are running Python, like any other standard language, you are looking to move data to the code. So, you are looking to move it out of local storage and looking to bring it into your computer, which adds latency. The other thing is the standard Python does not come in with a lot of the optimizations that the standard query engines have, which means your queries are going to run a bit slower. Right. Along with that, you want to be able to run Python in a distributed fashion. You want to be able to run it cloud scale and clusters, so that you can query petabytes of data. So, standard Python has challenges with doing just that. So, the obvious question is next, how do we bridge this, right? The first thing is recognizing that SQL and Python are complementary. You want to be able to use SQL when you query, aggregate, join your data and use the query engine optimizations. You want to use Python when you are doing complex analytics and you want to use the ecosystem of libraries from Python. And you realize that you want to use these together with a big data framework that allows you to run cloud scale over a big cluster, so that you can actually run efficient parallel processing. So, when you look at that, a common popular big data framework is Apache Spark. What we are seeing is organizations, several verticals, financial, healthcare, retail, are adopting Apache Spark. Apache Spark is a big data framework that allows you to run workloads of any size and run it efficiently cloud scale. So, you can run both Spark SQL, you can run Python, and it provides a huge ecosystem of libraries that allows you to spread it over clusters, so that you can run several of these in parallel. So, Apache Spark is great, but again there are a couple of challenges that customers run into. You need to set up the hardware and software infrastructure. On the hardware side, you need to provision clusters. Now, this becomes challenging when you talk of interactive applications. If you are running the same batch application day in and day out, you have a good sense of what your hardware requirements are. You can set the hardware beforehand. But when you are running interactive applications, you are actually actively exploring the data. You do not have a good sense of what the data looks like, what is the complexity of the job, what is the data volume. So, setting up a hardware infrastructure in this kind of setup is challenging. The other part of it is, if you are going to set up interactive applications, you want a fast start. So, typically to set up clusters, to get that start going, takes some amount of time. So, time that is actually wasted in terms of lost productivity, right. We have customers who set up an idle pool of warm resources waiting for interactive users, but of course, this leads to wasted idle resources. On the software side, Apache Spark requires you to configure settings. It has a large multitude of settings, which you need to optimize so that your workloads runs well. That is a big challenging for customers. In addition, we have software versions. We have software versions of Spark itself, we have software versions of Python, we have software version of all the ecosystem libraries. Keeping all of this in sync is challenging, and it requires also Spark expertise from our customers, and a lot of our customers do not have in-house Spark expertise. Ideally, they want to be able to have a fully managed serverless experience for Spark with minimal amount of expertise to run Spark itself, and we have an AWS service that provides a fully managed interactive experience, which is Amazon Athena. So, Amazon Athena is a serverless analytics interactive service, which gives you the simplest and fastest way to query petabytes of data. Whether your data is in S3, whether it lives on premises, you can get started quickly without provisioning clusters, without configuring settings. You connect to your data, you define your schema and start querying. You do not have to do any ETL, you do not have to process or move or copy the data. Now, Athena offers an interactive analytics experience on the console. It offers a query editor where you can start entering queries and start looking at the results. Alternately, you can use the APIs to interact with the data. Athena is open. It supports a lot of open data formats, JSON, Avro, Parquet, ORC. It also works with a wide variety of business tools, Tableau, Power BI. So, that is actually easy for you to work with it. The last part of it is it is cost effective. So, you pay for only what you use. So, it allows you to have very predictable cost with your analytics workloads. So, we are taking the best of all of these three and putting it together, and that is why we are introducing this feature. So, we are expanding Amazon Athena to support Apache Spark. So, you get the serverless fully managed experience of Amazon Athena. You get the the big data framework of Apache Spark that allows you to run efficiently cloud scale, and you get the expressivity and the wide ecosystem of Python. So, what does this mean for you as a customer? What do you get? So, the first benefit is you spend more time on insights, less time waiting for results. So, one of the key technologies that we have enabled in Amazon Athena for Apache Spark is instant start. So, applications start under a second. They not only start under a second, they actually auto scale up and down under a second. What this means is Amazon Athena looks at the amount of resources your application needs and auto scales the amount of compute up and down to match what your application needs. So, what this means for you is less waiting, but also what it means for you is you do not need to keep a warm pool of idle resources available. Along with the quick start, we also provide an optimized runtime that is faster than open source Spark, which means that your application not only start faster, they also execute faster. The net result is you are much more productive when you are running interactive applications. So, diving a little bit into the instant Spark infrastructure, instant start Spark infrastructure. So, as we mentioned, Athena provides instant Spark compute and the applications start under a second. And this is made possible because we use an ingredient technology called Firecracker, and this is the same technology that is available in AWS Lambda if you have attended the Lambda Snap Start session. So, this allows us to start 75x faster compared to other serverless offerings out there. So, if you look at the graphic on the left, you would see a typical Spark application. So, there is usually queries, joins, aggregates, and what you would typically notice is these stages, each of them require a different amount of compute. Most of our customers look at this and provision clusters to deal with the maximum, which means that you are going to waste a lot of resources. What Athena does, which is the bars below, it actually scales up compute efficiently and quickly to match what the application needs. So, the net result is you do not have wasted resources, but at the same time you are not spending any time waiting. The next benefit that you get is you can actually use Spark and Python to create complex and powerful analytics. Right? You can take advantage of the expressive power of Python to bring your complex analytics. You can use the wide ecosystem of Python libraries. In fact, we provide several Python libraries right out of the box for your convenience. In addition to that, what we have noticed is customers typically use notebooks as a user interface to work with Python code. you can enter applications, you can execute applications, you can visualize data all within a notebook. And once you have finished working with your notebook, you can share it within your organization. Now, Athena provides a simplified notebook experience on the console for you to enter and work with Spark applications. We also provide an example notebook that you can use to get started quickly. You can run the notebook and then modify it to match whatever your needs are. The next benefit is it allows you to focus on your business application and not worry about the hardware and software infrastructure. Just like Athena for SQL today, Athena for Spark is serverless. You do not need to set up or provision clusters. Athena will automatically determine how many resources you need and provide you the right sized amount of compute. What this means is you are not waiting for your IT staff to provision clusters or to start running your applications. On the software side, Athena manages the Spark settings. We often hear from you, our customers, that you do not want to be setting up Spark settings. They are huge, there are thousands of them, and getting them right to run your applications optimally is a challenge. Right? Most of our customers are business analysts, data scientists, and they just want to write the Python code. Since Spark runs on Athena hardware, we have a good idea of how to set them, so we manage the settings. So, what this means is you can actually use Spark, use the power and scale of Spark without having to worry about the Spark settings. The other part of it is we also manage Spark versions, we manage the Python versions, the library versions, and we also manage the operational items. So, you get a simplified purpose built experience for interactive applications. The next benefit is you can work with data where it lives. So, Athena for Spark supports a lot of the open data formats, JSON, Parquet, CSV. So, if your data sitting already in these formats, you would be able to point to the data directly in S3 and start querying without any pre-processing. Similarly, once you are finished querying and you want to write the data back in these open data formats, you can do so, so making your results portable across multiple software. Amazon Athena for Spark works seamlessly with AWS Glue. So, many of our customers use AWS Glue to crawl through their data sets and generate a meta store of database and tables. These Glue database and tables are available to work with Athena for Spark right out of the box. And we have customers who have their own business front end applications. These customers can use Athena APIs to work with data where it lives without having to move the data, process the data, query the data, and bring the query results back to their business application. Next, we talk about pricing. So, you pay for only what you use for Athena for Apache Spark. We charge an hourly rate, $0.35 per DPU hour, which basically scales on the amount of compute that you use. We measure compute in DPUs, and a single DPU is 4 vCPUs and 16 gigabytes of RAM. You are charged in increments of 1 second, rounded up to the nearest second. Now, if you used other AWS services with Spark, this pricing is going to look very familiar to you. We do recognize that it is different from the pricing that Athena uses for its SQL queries, and we have done this based on feedback that we received from you, from our customers. So, what we have heard from you is the compute based pricing matches much more closely with how you craft your Spark workloads. A typical Spark workloads has data queries, it has local processing, and it makes much more sense that we would have a compute based pricing when running Spark. So, when you start a Spark session, you typically have 2 nodes. You have a notebook node that actually provides a user interface for you to enter applications, and you have a driver node that coordinates the Spark applications. When you start running calculations, Spark provisions additional nodes called worker nodes that actually run the task of the application. On our side, we charge you for the driver nodes and the worker nodes, and we charge you exactly for the duration that they actually ran. We do not charge you for the notebook nodes. We give you the notebook node as a way for you to enter and execute applications, and this is provided to you free of charge. So, diving into a few different example use cases. So, as we mentioned, Athena is optimized for interactive workloads. So, the first obvious one is you have data in S3, and then you can use Athena with or without a Glue metadata repository to query the data that you have in S3. You might not have one data set, but you may have multiple data sets. You may bring multiple data sets which are structured, semi-structured, unstructured into your data lake, and they may be in multiple open formats. So, you can use Athena for Spark to bring all these data together to be able to join the data across these data sets and data formats to generate your insights. If you have your own front end business application, you can use Athena for Spark APIs to bring data to your business application. And if you are a data scientist, you can use Athena for Spark for feature engineering for interactive data exploration. You can use Athena for Spark to generate sample data sets, and then you can interactively work on feature engineering. So, we will dive into a couple of example use cases. So, the first use case is interactive data exploration. So, you start with having data in Amazon S3. You then can run AWS Glue crawler and start generating a data catalog, and this data catalog can itself serve as your metadata repository. Alternately, you can ask Amazon Athena for Spark to directly infer the schema of the data that you have in S3. Once you have the schema available, then you can actually have notebooks to enter calculations, to enter queries, to enter data, and interactively work with the data. The other use case is when you have your own business front end applications. You want to provide interactive web applications you want to your business end users. And the way it would work is this: your business end users would log into your business application. They would write interactive queries, or you could have interactive widgets in your web applications. And they click on these interactive widgets, that in turn will generate queries. Now, your business application will then use Athena for Spark APIs to query the various data sources, aggregate the data, and process it in a form that your business application needs. And once it gets that, the business application then presents this data to the end users. Next, we will talk of how you can get started. The first step is creating a work group. A work group in Amazon Athena is a resource that is used to separate users, applications, teams that share an AWS account. We set up resource based policies to set up access to these work groups. A typical example is you may have two different users sharing the same AWS account. You can actually put them in two different work groups so that they can access each other's work. You can also use work groups to limit access to databases, tables, and other resources. And the way you do that is through IAM roles and policies. So, you set up IAM role as part of your work group creation, which makes sure that users in that work group have access to only specific resources. Now, on our console, we provide a simplified work group creation. So, we provide smart defaults for IAM roles to give you the right permissions. We create an S3 bucket that you can use to store your working results. Now, alternately, you can create your own IAM role, you can create your own folder and ask us to use that. For a lot of our customers, encryption is very important. So, we provide notebook encryption. We also provide encryption of the S3 folder. You can use an AWS key that is managed by Amazon Athena, or you can actually bring your own KMS key. Once you create your work group, you can go to the Notebook Explorer to see the various notebooks you have inside your work group. You can create one from scratch. You can actually import an existing notebook from your local desktop. And once you have a notebook available, you can rename the notebook if you desire. You can click on the notebook to open the notebook. And once you have finished working with it, you can save the notebook and you can export it to share it with a new organization. So, next we are going to talk of the notebook editor. So, we provide a simplified notebook editor interface on the console for you to enter applications. You can start with the example notebook that we provide, or you can build your own. We provide a Jupyter based notebook experience on the console. A lot of Python users who have used Jupyter before would find this experience, this interface very familiar. We also allow you to work with multiple notebooks at the same time. We do that by providing a tab notebook experience. Each notebook that you open opens up in a different tab, which allows you to work with multiple notebooks at the same time. You also get an independent Spark session for each notebook that you create, and you can actually set session specific parameters for each notebook. So, each notebook you can set how much DPUs you want to use, how much you want to set for the idle timeout. So, you can set all of this independently. Once you execute your calculations, you can actually go to the session detail page to see the details of your session. You can see all the calculations that are run as part of the session. You can click on any of the calculations to see details of the calculation, how long it took to run, what is the standard out, what is the standard error. You can also click on the link to S3 to download the results to your local desktop. So, with this we give you an idea how you can get started. Next I am going to give it to Ravi, who is going to talk of an exciting use case that Finra has built using this feature.
Thanks Raj, it was a great session, and thanks everyone for coming. I am Ravi, Principal Engineer at Finra, Financial Industry Regulatory Authority. As a Wall Street regulator, we run advanced analytics across a very large set of data set using cutting edge AI technologies. So, I am sure you all have need for analytics. Some of our needs are large and some of our needs are extraordinary. As organizations, we continue to think about how we can interactively provide analytics to the user. As organizations deal with variety, volume and velocity, I want you to think about, are you as end users empowered to perform analytics that will enable you to ask better questions? So, today I am going to talk about how you as users can perform analytics at scale and not worry about infrastructure. But first, a little bit introduction about Finra. Finra is the largest independent regulator of financial market in US. We are dedicated to investor protection and market integrity. We do this by running big data across large set of data using data science technologies to detect fraud. We ensure that the firms are abiding by the rules that enable them to not do any fraud in the first place. We refer any anomalies to discipline those who break the rules. Today, Finra regulates about 3,400 security firms and 630,000 brokers. So, we take in about 600 plus billion transactions each day. These are the orders, quotes, trades and cancels. We run surveillance on top of this to build market events. We do this by spinning thousands of clusters and hundreds and thousands of EMR nodes each day. So, we not only collect the data and process it, but we also look at the data going back 2 years. So, right now our data lake takes in about 500 plus petabyte of data and continues to grow each day, and we are growing at the rate of 20 to 30% every year. So, what does our data stack looks like? So, as I mentioned, we receive the transactional data from the stock exchanges and the brokers. The data is sent through series of ETL transactions or the ETL pipelines to validate, enrich and link the data. the data, process data is published to S3. So the compute, we use transient EMR clusters to process the data, and the data is, the compute is lineated from the storage. So the storage that resides in our data lake is of open format and is agnostic of any query engine. This is important for us as we continue to modernize our query engine. Earlier when we started our cloud journey, we used to have Hadoop and Hive. Now we use Spark ecosystem that includes PySpark, Scala, and Spark SQL. Along with, we also use the machine learning and the AI technologies that includes TensorFlow and SageMaker. So all good so far. The data is in the centralized data lake. The batch analytics has delivered the relevant information to the users. Now the users wants to look at the data. They want to seek all the relevant information in their entire organization. Does it sound familiar to you? So I want to talk about the search and discovery part first, and then we drill into the interactive analytics part through the session. Now, in order for any organizations to provide interactive analytics to the user, it is very important for them to provide the ability for the users to discover the data. They want to see what data resides, where it resides, and how do they access the data. So we have our data management tool. Going back to how the data is being generated, the data engineers, as part of the data creation, they register the data in our data management. They register the details about the object, they register the details about the schema. Now, they also register the information about the column, like the description, what that means. And they also provide the tags that go along with it, like what kind of access they can, the users need to do in order to get the data. We built a UI on top of the data management tool called Universal Data Catalog. So what this provides the user is they can go to the Universal Data Catalog, they can put in some keywords, and that they will get the relevant objects that may have the data that they are interested in. They also see the tags that they go along with it. So if they don't have access, they can use the tags to request access, and if they're entitled, they can get the data back. So now the users have options. Using the insightful information that was provided by the batch analytics, they can go to the UI and get the data, or the data that was sent through the batch analytics, they can use that and use Presto SQL to analyze the data. So I want to dig deeper into what are the different kinds of users who are using this data and what are the challenges they have. So I want to drill deeper into two users who constantly analyze the data. First, the business users who want to know right away what happened in the market. They want to be agile and nimble, and they want to see what's happened, and they want to quickly respond to the data. The other set of users are the data analyst. The data analyst wants to reconstruct the market to see what happened at any given point of time. And there are two reasons for this. First, they want to better research the market and see what's the trend. Second, they can use the data to create better features and build better models. So we have data in our data lake. We have about hundreds and billions of records. We created, using our ETL pipelines, the summary data, statistically significant sample data, and also the metrics data using our metric-driven framework. Now the batch analytics run on top of this to provide relevant actionable intelligence to the users. So how do these users access the data right now? So there are two kinds of users I just mentioned earlier. So the users use homegrown UI tool to dig deeper into the data that was provided by the batch analytics. They can provide the time, date, what is the symbol and what's the form to look at all the data that is based on this summary, samples, and the matrix data. Now they want to dig deeper into what's going on in the market. In those cases, they can go to the Presto SQL. As I mentioned, they can use the universal data catalog, know what's the object. They can plug in the object in the Presto SQL and analyze the data. The SQL sits on top of persistent EMR cluster. And the EMR cluster uses our Hive Metastore to get the data from our data lake. So now the users can look at the data, but there are a couple of challenges I want to talk about. Once they start accessing the data and build their queries, it gets too complex. I think you maybe all be familiar with this. As many objects they join and then they build the query, the complexity gets bigger. Also, because we have such a large data ecosystem, sometimes the query can go only so far. And also on top of that, they want to visualize the data. That's a challenge as well. Now, because of the large data set, if they want to analyze, they can go to the engineers. Now let's see what engineers can do. They can either query the data from Presto SQL, or they have more power. They can create a transient EMR cluster. They know about the data, so they can go to the EMR cluster and plug in the information that EMR cluster needs, such as what's the instance family, instance type, and how big the instance should be, and the cluster comes up. They use the Python code or our favorite language, and they can get the data. They can also tune the code using various Spark tuning parameters that is available to them. Now, they have the data. They provide it to the engineers, business users. This all works well when market works in a predictable manner. But there is never a dull moment in market surveillance. The landscape constantly changes with the market behavior. Anyone remember meme stock? Yeah. So let's say a market event happened with one of the meme stock. So our batch analytics using AI technologies has delivered some anomaly and relevant actionable intelligence to the users. Now the users know what happened in the market, and they can plug in the information to look at the data using the pre-canned report in the UI. Now let's say if they want to drill the data deeper. I want to talk about a little bit about our data lake. So we have data in a data lake with hundreds of files in a partition. And we have about 2,000 partitions. And I'm talking about this is just one object. We have about 2,000 partitions with hundreds of files. These are like, again, large files optimized for performance. And we have data across multiple years. Now, the users wants to look at the data only for that time where the market event happened. That is the scale of the problem we are talking about. Now, as a user, I can either use the Presto SQL, but in this case, it will not work because of the large data set, or I can go to the engineers because I can't do myself as a user. I do not know what the cluster means or what the EMR means, what the instance family, instance type means, and also I don't know what the Spark tuning parameter means. I can do all these things, and I don't have time to deal with all of these things because I only want to do what I do the best, just analyze the data. So this is the problem that we keep hearing from users again and again and again. In order for organizations to provide interactive capability to the users or any analytical tool to the users, the biggest organizational challenge that they have is the ease of use. When we heard about Spark and Athena, we thought that this could fill the gap potentially with interactive analytics across a large set of data set. So we started working on our POC. So we created a same-day data set in our development environment using the Parquet file. We used Spark and Athena, and used our Plotly library, which was available within the, within the Spark and Athena notebook. We also used our own library to connect to our data lake using the Glue catalog. So what we found? We found that we get instant notebook. This is a game changer. Now imagine this. Users can perform analytics as soon as the data is given to them using the batch analytics. They do not need to rely on any others. They do not need to configure anything. And they can use the program of choice to analyze the data. This is very critical. So now the users have access to the data, access to the Python notebook. They plug in the code or write the code. So as soon as they start the notebook, it starts with one DPU, which is the one Spark driver. I don't want to go too much technical, but it starts with one driver node, so which corresponds to one DPU. Now, as and when the user starts running the steps, these are called as the calculation. So as and when the calculation gets started, the DPUs automatically scale up and down. This wouldn't have been possible in any other environment where we have a constant cluster even with the persistent or transient cluster. So this solves the scaling problem. But we also think that this also could solve the concurrency problem. Now imagine I mentioned about the Presto SQL that runs on the persistent EMR cluster. Whenever there is a big market event happens, we have seen that all the users get into the Presto SQL and dissect the data across different form, so the load gets more, and we see concurrency issues. With Spark and Athena, we believe that the concurrency issues will be lower because the DPUs are segmented within the Athena workgroup. So with expressive language such as Python, they can create the code legibly. Even if it is complex, they can split up the code, and they can use the libraries of choice, and there are like various libraries as Raj mentioned, or you can bring your own library. They can use Plotly or Matplotlib to create a chart. Now they can understand the data better because that is providing a visual story to what's going on. So what we found is also the data sharing is easier. So they can not only share the notebook with their user, but they can also share the data. How? As and when the user creates, user executes the notebook, the data can be written to the S3. Now the buddies within my team all share the work group. I'll talk about the securities shortly, but all share the work group so that they can access the notebook and they can also access the data. So now coming to the cost, I mentioned about these DPUs. These are compute cluster nodes that automatically scale up and down. So other users who are looking at the data, if they are idle, like I'm not doing anything, just only the minimal driver node or the minimum number of DPUs are running. So this way we are saving on the compute cost. We have also seen that with a flywheel effect, as more and more users start to use the data, there is a lot of, start to use this Python notebook, there's a lot of data that comes into S3. We can use lifecycle policies to transition to intelligent tier. This way, we can save on the storage. So back in our example with our POC, even though we had about 12 terabyte of data, since the users, or we, as part of our POC, we were looking at a symbol and a specific time, we loaded only few gigabyte of data into Athena in the first place. And this was possible going back to our original design principles to partition the data in a right way that is performant for user queries. Now, coming to the security, as Raj mentioned, the compute is in the internode encryption is happening. So there is an encryption at transit. The data is written to S3, so we have encryption at rest. All my buddies are part of the work group, and that work group is tied to an IAM role. So we all have shared same access, and the IAM role can have access to certain data set. So that way we are covered with access granularity. I also want to talk about the CloudWatch and the CloudTrail. All the metrics are published to the CloudWatch, and all the logs are in the CloudTrail. So as an organization, you can use your own monitoring tools, such as we are using Grafana and Prometheus, to understand what these users are doing, and also what is the DPU that they are using, and what kind of objects that are accessing. Particularly we being in a regulatory organization, this is very critical for us. So what I told about the users that are facing the challenge, so this is what we found. So what does this show? This shows that as an user, I am empowered. I do not need to know about any of the compute-related stuff, also any Spark-related stuff. I just do what I do my best, analyze the data. I can create like charts using the Plotly library, and I can share this data to my buddies, and we can come up with a conclusive decision as to what needs to be taken. In this case, we see that there may be a potential manipulative behavior happening in one of the firms interacting with the symbol that caused this specific stock to come down in the last 2 minutes. So with this, they can reach out to the firm to see what's going on. This is powerful. So here are the key takeaways that I want to provide based on what we found with Spark and Athena. Again, reiterating what I said, faster analysis. Now users can analyze the data as soon as the data is available. They can dig deeper, how large it may be, and they can create their own libraries to provide visual stories by using like Plotly as an example. So with the better visualization, they have story to tell. Yeah, we know that a picture is worth 2,000 words. So with that, they can ask right questions, better questions. And the users are empowered. They don't need to rely on the friends from technology. They can do all the analytics on their own. And the data analysts can do deeper analytics on large set of data that will enable them to make their models better, create better features that can detect the fraud sooner and better. These are very powerful impact statements, and these all are tied to our organizational goal: investor protection and market integrity. But our innovation doesn't stop here. We continue to see what is better for us, what is better for our users, and to provide the latest tools. So Finra started Cloud Journey way back in 2014, even before Glue was available. So all our Metastore or the data catalog is based on High Metastore, and Athena supports a Glue catalog as a first-class citizen. So we want to work on this space. We already have a tighter security posture when it comes to providing access to the users. But we want to make it better for the users to come and seek the data that they want, and then they request the data that they need. We already started working on this space and continue to evolve as newer and newer technology comes up. And with a lot of users starting to use Spark and Athena, we also want to enrich our CI/CD pipeline in this space. We want to make the option for the users, or not the option, but make the possibility of the users to check in the data, check in the notebook, and also enhance our CI/CD pipeline to be able to deploy the Spark and Athena notebook across multiple environments. Great tool. Thanks, Raj, and I'll give back to Raj.
Thanks, Ravi. So with that, you can go to aws.amazon.com, Athena Spark to learn more about the feature. Thank you for coming.